Okay, the last page here we have some word problems to do. Number 14 says the number of food trucks in a city has been increasing by 50% annually. There were 2 food trucks in the year 2010. Write an exponential growth function that represents the number of food trucks T years after 2010. So first of all, I know I have an exponential growth function, and I know we increase 50% annually. 50%, let's start here and let's figure out how am I going to write that as a decimal. 50%, move the decimal point 2 spots, and it's 0.50. So when I go to write my equation, we start y equals my starting value, and it says there were 2 food trucks that year. We're increasing 50%. So I need to have 1 plus, because that tells me that this is what I start off with, and I'm adding my 50% here to the t power. Part B asks, how many food trucks will there be in the year 2030? Well, the year 2030, I need to figure out, well, what am I going to plug in for t in my equation? It says t is the number of years after 2010. 2030 is 20 years later. So what I need to do is take in my equation up here, take 20 and plug it in where t is. And then type this equation in your calculator. 2 times 1 plus 0.5 to the 20th power. And it looks like there's 6,650.5 food trucks. Now I'm actually going to round that down, 6,650, because I don't quite have the 6,651st food truck. I only have 6,650. It also says to explain all of this work that I did right here, where I took 20, plugged it into my equation, that's my explanation. My work is my explanation. All right, number 15 says Target has profits of $300,000 that are increasing 15% each year. Walmart has profits of $500,000 and is increasing $10,000 each year. Write an equation that represents the value in dollars of each store after T years. Let's start off with Target. Says we have profits that are increasing 15% each year. When I see that percent, that tells me that I have something exponential. Increasing by a percent is something exponential. 15%, move that decimal point 2 spots, is 0.15. So Target's equation, y equals what our starting profit was, 300,000, times 1 plus 0.15, because we're increasing, to the t power. Now we're going to write an equation for Walmart profit also. But here's the thing with Walmart. Their profits are increasing $10,000 each year. We're not increasing a percent, we're increasing a set amount. And that set amount tells us we have something that's linear. Linear has a constant rate of change. So for Walmart's equation, I don't have something exponential. I need to use this formula, y equals mx plus b. All right, so Walmart. The m is our slope. That's what we add each year. And that's $10,000. We start off y equals 10,000x plus our starting profit, 500,000. There's my equation. Part B asks which store has more value after 5 years. Explain your reasoning. I'm going to take 5 and plug it in for t in both of these equations. Or I guess I should have used a t here. So target, 300,000 times 1 plus 0.15 to the 5th power. And it's really easy to add an extra 0. We get $603,407.16. And then same thing with Walmart. We're going to plug 5 in where the t is. 10,000 times 5 plus 500,000. Plug that in your calculator. Oops. And that's $550,000. So Target has more value after 5 years. Okay, last 2 word problems, and these ones go a little bit faster. Number 16, in 2015, the population of bees in the United States was studied. The equation y equals 3,000 times 1.4 to the x power models the number of bees y in the United States x years after 2015. What does the 3,000 represent? 3,000 is our start value. That's your y-intercept. The y-intercept in this case means that's our start value for the number of bees. There were 3,000 bees when we started. Well, when did we start? In 2015. Part B asks, what does the 1.4 represent? Well, that 1.4, your B value, get it? B value, B's. Anyway, this number is more than 1. So that tells me that the population is growing. Let's figure out how much the population is growing. I want 1.4. I'm going to do this over here. 1.4, that tells me what 1 plus r equals. I'm going to subtract 1 from each side. And I get 0.4. That's 40% each year. All right, one last question. Number 17. A school population was 1,200 in the year 2010. The number of students decreases by 6% each year. Write an equation that represents the population t years after 2010. Okay, we start off with 1,200 people. And then our population decreases 6% each year. I need to figure out how can we write 6% as a decimal. It's 0.06. You can always double check after you have the decimal written. Move that decimal point back 2 places to the right. Double check to make sure it's going to match up with what you want it to be. We move this decimal point 2 places to the right. I have a decimal point after the 6. That's our 6%. Now we are decreasing our population, so I want it to be 1 minus 0.06 to the t power. Then part B asks, how many students will attend school in 2018? Round your answer to the nearest whole number. In 2018, that is 8 years after 2010? So that means 8 is what I want to plug in for t in my exponent. Oops. We're going to type that in. 1 minus 0.06 to the 8th power. And there's 731.48 students. Well, round to the nearest whole number, we have 731 students.